Hi dear students, in this video I'm going to explain experimental probability, and experimental probability sometimes it is called relative frequency. Firstly, we know what does experiment mean in math when you're also if you do the experiments like here drawing a pin here, and this is the experiment. Each time when you do this one it is called trial, and when you record the results here, frequency table you are going to find. And with respect to your frequency table, number of successful outcomes divided by the number of total number of trials, it's going to give you the experimental probability result. As I said before, we were learning theoretical probability, and theoretical probability here, if it is theoretical probability, then if you roll the dice, if we are talking about dice here, I give an example on the dice. If you roll the dice 12 times, each expected to be equal, because if it is fair, it should be equally likely should come, which is, let's say, 2 times here, 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 and 2 times here it should be, which is also 2 divided by 12, that's equal to 1 over 6. Actually, for the 1 probability of 1, it's going to be, with respect to theoretical probability, it's going to be equal to 1 over 6. But experimental probability, different. Firstly, you are doing your experiment, you are recording your results, then you are getting the probabilities with respect to your frequency table. Here I'm going to do on the dice, and I'm going to use this app for the recording my results. It's rolled for the first time and it's get here 1. So I'm going to tick here once, then I'm going to roll 12 times, 11 times once rolled, 11 times more, then I'm going to record all the results. Second time I'm rolling and it gets 2. The third time I'm rolling it gets 5. Fourth, 4. Fifth, 1 again. 6th, 5 again. 7th, 2 again. 1 again. This is the 8th time. 9th, 1 6. Here 1 3, yeah. And one more time I'm going to roll here 1 6 again. Here, if I count, I think one more time, 2, 4, 6, 8, 11. One more time I'm going to roll, and this is 6 again. So with respect to our experimental probability, the result is not equally likely, like 2, 2, 2 here. What it is, here 3 times 1 shown, 2 times, once we have seen 3, once only 4, so 2 times 5, and 3 times 6 we have seen. So this is the experimental probabilities result, and probability of everything here, probability of 1, probability of 2, I'm talking about theoretical probability, all they are 1 over 6. For the experimental probability, the probability of 1, it becomes 3 over 12. Since totally there are 12 times we did this experiment, 3 over 12 it's going to be. What is the probability of 3? With respect to our table, it's going to be equal to 1 over 12, because as I told you before, we rolled 12 times. Now we are going to continue with the examples. Julia spins a spanner 150 times. It shows red 40 times. And the question is, what is the experimental probability that spinner shows red? So experimental probability with respect to given information we are recording, and it says that the probability of the event, it's going to be always wanted event divided by all events I said. And wanted event here it is 40. Probability of red is equal to probability of red is equal to 40 divided by 150, it's going to be. which is equal to, at the same time, 4 over 15. Okay, the second part, probability experimental, what is the experimental probability? That the spinner does not show red. Experimental probability or theoretical probability doesn't matter. The probability of everything is going to be equal to 1. I mean, probability of red and probability of not red, when you add them, the result, it should be always 1. This is the A, and now I'm solving B. So it should be equal to 1. Again, I'm repeating, probability of everything is always 1, which means probability of red and probability of not red. These are the most possible cases here. It will be red or not red. So the total sum of the probabilities of these two conditions, it should be equal to 1 always. So when you want to find the probability of not red, you should get 1 minus of probability of red, which is sent to other side. And we know that probability of red from the experimental probability from the A part, that's equal to 4 over 15. So 1 minus 4 over 15 is going to be. And to get this answer, you are going to multiply 15 times 1. Then you are going to subtract here 4, which is equal to 15 times 1, 15, minus 4, it's going to be all over divided by 15, which is equal to 11 over 15. So if I write here again, probability of not red is equal to 11 over 15 going to be. Okay, this is the third part, the C part. The spinner spun 200 times and estimate the number of times spinner will show red. Since the probability of red is equal to 4 over 15, it's asking that if the all possible cases probability of red for the 200 spin, what it should be here. How many times red it will show when you do this one 200 times. So when you do 150 times, it shows 40 red, which means 4 over 15. It should be equal to, here I'm going to use, instead of this question mark, x over 200. By using cross multiplication rules, I'm going to multiply 4 times 200. It's going to be equal to 15x, which is 4 times 200 divided by 15. It's going to be give me x. I didn't do this one here. I didn't multiply because maybe I may simplify, and I'm going to simplify 200 by 5 here. It's going to be equal to, if you simplify 200 by 15, this is going to be here. If you divide by 5, this is going to be 40. So this is going to be equal to 3. So the x will be equal to 160 divided by 3, which is approximately, when you divide 160, if you divide 158 or 559, that's going to be equal to 53. 159 divided by 3, it's going to be 53. So 1 divided by 3, it's equal to 0.33. It continues. You know that one? So the approximately answer is 52.3. But to show the red cannot be decimal number because it will show red or not. That's why approximately the answer probability of red after 200 times, it will be 53 approximately, and we should write here 53 divided by 200, 4 over 15. They are going to be same number also at the same time. Here I'm going to continue with the new example here. Thomas planted a bag of mixed tulip bulbs in his garden. All the bulbs grow and produce one flower each. The table shows the colors produced by the bulbs. When they flower, the color is red, yellow, orange, and purple. From red we have 8. From yellow we have 32. From orange we have 6. And from purple we have 4. How many bulbs does Thomas plant? This is the important part because we are going to, this is the all possible cases. So 8 plus 32, which is equal to 40. And then 6 plus 4, that makes 10, and 10 plus 40, that makes 50. So the answer is 50. Work out the relative frequency each color. So probability of red, this is the A, and A is 50. And B, probability of red is equal to 8 over 50. If you divide by 2, it's going to be 4 over 25. Probability of yellow, it's equal to 32 over 50. When you divide by 2, it's going to be equal to 16 over 25. Probability of orange, it's equal to 6 over 50. When you divide by 2, it's going to be 3 over 25. And probability of purple, it's going to be 4 over 50, which is equal to 2 over 25. It's going to be. Okay, we're going to use our answers in part B and estimate the number of purple flowers that will produce purple. A bag containing 240 mixed bulbs, which means if the sum is 250, what will be the probability of purple? Yes, purple here. So it means that probability of purple, if it is 4 over 50, then probability of purple, this is for 240 bulbs, how many purple bulbs will grow up? So 240 times again I'm going to use the cross product here. That's going to be 4 times 240 divided by 50. Here I'm going to do like this. We are going to simplify this one. Then 4 times 24, that's 96. It's going to be 96 over 5, which is equal to 192 divided by 10. It's going to be, to do decimals, that's why I multiplied 5 by 2 and this one by 2. Then when the denominator is 10, I'm going to divide easily. The answer is going to be 19.2. This is 19.2, but 19.2 bulbs cannot be. That's why the number of flowers, it's going to be 19 here. The purple flowers, it's going to be 19 approximately here.